Hi everyone. This is a closer look at a reaction pathway analysis. I have this reaction pathway drawn on the board beside me. It shows both a catalyzed and uncatalyzed pathway. I have put some values on the y-axis, and we're going to interpret this reaction pathway in order to answer these 6 questions about it. Let's see if we can find the delta H from the graph, the forward uncatalyzed activation energy, the reverse uncatalyzed activation energy, the forward and reverse catalyzed activation energy, and in the end, let's decide if this represents an endo or exothermic style situation. In order to answer these questions, we want to use the values on the y-axis, but it's really important we know which area of the graph we're focused on. Let's take it really methodically and deliberately. The first question is asking us for the delta H, the enthalpy change. Recall from our work with potential energy diagrams that the delta H, the enthalpy change, is the change in potential energy. It's always going to be the distance in between the 2 horizontal lines. That area right there represents the delta H. The delta H. This first horizontal line where the reactants are is at 25 kilojoules. And this graph comes down all the way to 5 kilojoules. It's coming down. This represents a loss in potential energy, a loss of energy, a negative delta H. Here we are at 25, we end at 5. That's a change of negative 20 kilojoules from 25 down to 5. The forward uncatalyzed activation energy. The taller part of the graph here is the uncatalyzed section of the graph without a catalyst. The one in red here, the alternate pathway, where the activation energy has been lowered, is the catalyzed part of the graph. So the forward uncatalyzed activation energy it's that part of the graph. The activation energy going forward up to the elevated activation energy, not the red one. This is from 25 up to 27.5 on the y-axis. From 20 up, that's 32.5. From 25 up to 32.5. That's a change of 7.5 kilojoules. That area was going up on the graph. It's a positive change, positive 7.5 kilojoules. The reverse uncatalyzed reaction is from the products all the way up to that same peak, the uncatalyzed reaction pathway. This time it's from 5 all the way up to 32.5. 5 up to 32.5 is 27.5. Again, it was going up. It was a positive change. It was a positive 27.5 kilojoules. For our catalyzed part of the question, I'm going to switch to red. Notice we had the forward uncatalyzed reaction, and now the forward catalyzed reaction. Here's the forward, we went up to that peak for the uncatalyzed reaction, but now we're going to follow the red. It's a much smaller value. Please recall, a catalyst decreases the activation energy. So it's a normal thing for us to see lower values than the uncatalyzed ones. This is from 25 up to 27.5. 25 up to 27.5 is a change of 2.5 kilojoules for our forward catalyzed reaction. The reverse catalyzed reaction, it's the same area. This tall blue arrow here was the uncatalyzed reaction from the products all the way up to the top of that peak, but now we're just going up to the red with the catalyzed reaction. That area of the graph. It's from 5 kilojoules up to 27.5. From 5 up to 27.5. Is 22.5 kilojoules. From 5 up to 27.5. Finally, we're being asked, does this whole situation represent an endothermic or an exothermic type of reaction? There's a couple of different ways we can tell. The easiest way is from horizontal to horizontal was a downward movement. We have an exothermic reaction. This is confirmed by our delta H, which was a negative value, which also coincides with the idea that this reaction is exothermic. There are times where we might be given a reaction pathway that shows both the uncatalyzed and catalyzed situations. There are 6 possible questions we could be asked. We're not going to get all of these all at once, like this example. There's 6 possible questions. It's very doable. We just have to be careful reading the values off the y-axis. However, it does put a lot of emphasis on making sure that we're focused on the correct section of the graph. And I hope that helps.